Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is the Alienware again. So this is the same laptop we diagnosed last time. What was wrong with it? Well, number one, it overheats. Number two, it does not charge the battery, or it charges the battery, but it charges it with roughly 1 milliwatt of power. But it is charging, the battery is not locked, the battery health is presented as 100%, and the charging cycles on this battery is 1. Now, last time we pushed some current into the battery and the battery wouldn't accept any. For that reason, I got the replacement over here, brand new battery. Just to satisfy my curiosity. Now, I did say that I have to go by what I see, right? If the battery is not accepting current, then that's the problem, right? The battery is the problem. Obviously, the customer did say that he replaced the battery, and I believe him. But again, I have to go by what I see. So that was my conclusion last time, but that is not a definitive conclusion because the battery will not take charge more than needed unless you properly communicate with it to start accepting that charge. So the problem could be somewhere else, and we're going to figure it out. Now, we do have liquid metal, as recommended by you guys, that this machine 4090 is always going to overheat with the regular, even high performance thermal paste, which I put on it. Now, here's the initial diagnosis. The laptop is overheating, but we did notice that it's overheating in BIOS, right? If you go into BIOS, the laptop is burning up, but it's not the GPU that is burning up, because GPU is not even going to be powered on in BIOS. The display adapter being used is the built-in Intel display adapter, and when you log into Windows, it uses that display adapter or that graphics card, the low performance battery saving graphics card. Once you start something that is GPU intensive, it's going to switch to 4090. But based on my observations and my measurements, the 4090 is heating up to roughly 87 degrees, which is a little high. It's not horribly high, but I would like to see it closer to 80, even below 80. And the maximum of maybe 83. 87 is a little bit high, but not alarming. But it's not the GPU that is overheating, it's the CPU that is overheating. We have i9 over here, Intel Core i9, and I have some suspicions. Now first, let's take a look how versatile this machine is. It has been shipped to me and back twice now, and on each time it was not properly packaged. So once I received it, you doesn't even need to unpack the box. You can just reach in and pull the laptop out, because it was rattling inside enough that it just completely destroyed the box. I advise the customer to use the reinforced or heavy duty boxes that you can get at Home Depot or what have you. So there's like dents everywhere. There are cracks and stuff, deformations, but I ran the laptop. It started right away. There are no issues with the display. I ran benchmarks on it to get the measurements of the temperature and stuff. Everything is fine. This is a very sturdy laptop. Even with improper packing and just basically dropping from the second floor, there is damage, sure. There is damage, but the case managed to absorb that damage, and nothing inside actually was was damaged. In addition, the board is not super secured. There are some screws missing here and there. And again, it just works. So Dell Alienware, this is M16 R1, very sturdy machine. It can survive a lot, apparently. Now, once we open it, again, there is no damage, visible damage here. All the fans are spinning, so the cooling is working correctly. But the area that is heating up is this, right? This part of the board. Now, this part, as you can see, is right next to the CPU. The GPU is over here. These are one of the coils on one side, and there's a row of coils on the other side. And this looks okay, right? The GPU doesn't seem to be overheating, at least not much. So the liquid metal definitely is going to drop a few degrees of the GPU, but it's not the GPU that is overheating. Now, why would the CPU overheat? I'm not sure yet, but one thing that I observed, and this could be, I mean, it was overheating before, right? And that's why the customer first replaced the paste, and then I replaced the paste. So probably that's not the reason, but I noticed that these screws are all the way in, and these are a little bit deeper. So do we have improper, the heatsink is not sitting properly flush on the CPU, and it's a little bit lifted on one side, and that's causing overheating. That could be it. But I find it hard to believe that twice I replaced the heatsink improperly. And on the heatsink, you have the numbers, which screw to tighten first. But even with that, I first do one turn on one and on the rest. So it's not like I put a full torque on one screw and then I move on to the other screw. They all just kind of come down at the same time, and then when it comes to final tightening, I do it in the proper order, right? So it should sit properly. Maybe it doesn't. Maybe that's the problem of overheating. Because to be honest, this thermal paste that I used is good enough. It shouldn't be overheating. Now, liquid metal might give you a better performance, as per comments that I received on the previous video. My approach was that the only difference between those two is that the liquid metal doesn't go old. So once you replace it, you can keep it for years and nothing will happen to it. The thermal paste will go dry and will lose its properties over time. But experts in my comment section seem to disagree with that, and I'm inclined to believe them. I don't specialize in this, right? Now, for the charging, I can't show it to you yet, but we've seen the board in the previous video. And what I did, I wanted to catch the initial charging period when the voltage goes up and then drops. And I did. But after seeing that footage, now it occurred to me, because I missed that when I was actually doing that. It went up to, what was it, 15 volts? Something like that. 14, 15 volts. That's too high. According to the schematics and to the board view, the voltage here should be 12.6 because the battery is 11.4. So the charging voltage should be 12.6 roughly. The suggestion I got in the comments more than once and more than twice was to check the MOSFETs, because shorted MOSFET can cause such an issue. Now, typically I don't do that, but when I don't have any idea, then yes, I just go component by component and I check it for resistance or shorts. So I did that. Both visual inspection and measurements were negative for typical faults. So now let's review, since we have the board view now. So this is the charging coil that I showed you guys in the last video, which charges through the resistor, the big current sensing resistor, and we have these two that go to one side and the other side, and that goes to our PMC, right, to measure the voltage, to measure the current. So power charging CSOP and power charging as FSET, right? These two pins are responsible for measuring how much current is flowing through this resistor, right? The coil is controlled by or driven by these two transistors. This is low gate, going to our PMC directly, no resistor, and our upper gate or high gate, again with no resistor, no nothing, just going to this chip, right? This chip is 9552 ISL. So from this resistor we can see that we have few capacitors here and there, so it's good to check, because one of these could be giving us issue. There's also a small resistor over here that also goes to ground, and all of these go to ground. So we have this array of caps on the output, and that, if we flip around the board, goes directly to our battery connector here. All right, B+, the first three on the right. So our assessment, without the schematic, our assessment was correct. The schematic that we had for a similar chip is correct, so all of our assumptions were correct here. Now, one thing that I didn't know was, where does the power come from? It's through this resistor and those two transistors here. Let's see. Okay, so looks like these transistors are just switches. They are not driving anything here. They are just switching our 19 volts from the battery to supply to this transistor 19 volts, and that in turn converts it to charging voltage. Now, I do have a replacement for a PU4401 ISL 95522. I actually got a few of them, but I really don't think it is the faulty chip, because that kind of fault, the chip is communicating with the computer. It's reporting how much power does the battery consume, what is the charging voltage or charging power, charging current. It's at 1 milliwatt, so that's why the battery is taking forever to charge. But I think it's the chip that identified that something is wrong, and that's why it's limiting the charging. So one thing that could do it, and I've seen it on, I can't remember the name now, but an excellent technician that specializes in Dell laptops. I've seen it on his video that the issues with charging, that was actually issues with on main power rail, so not with charging. We don't have issues with main power rail over here, but we have issues on this coil basically, right? And what I figured is that this coil could be faulty, and typically coils don't go faulty. I mean, they don't go faulty. Well, they do go faulty, but it's very difficult to actually confirm whether the coil is faulty or not, because you can't just measure the linear properties of the coil. You need to measure its actual reactance, and that is dependent on what you put on the coil. So for that, you need an oscilloscope and knowledge of some relatively simple equations, but it could be a little overwhelming. So first, what we want to see here, right, during the first charging period, that first initial charging, we want to see a stable voltage on this coil, or at least on this resistor, because we have good capacitance over here. But even with that good capacitance, with before the resistor over here, we should still, on this pin of the coil, we should still see relatively stable voltage. If the voltage is all over the place and it's choppy, then the coil is most likely resonating. What would cause the coil to resonate? Typically, it's the physical damage to the actual coil, which is inside. We can't really examine it. We can't really measure it, not with the tools that I have, or without creating a very sophisticated testing circuit to confirm that. But we already have the circuit here, right? It's already in the laptop. So all we have to do is confirm that we have stable voltage over here. If not, we're going to replace the coil and see if that helps. In addition, we're going to replace, if that doesn't help, we're going to replace the PMC. We have plenty of these now. And that should resolve the charging problem. Because again, the only MOSFETs involved over here are these two, and past these two MOSFETs, we don't have any MOSFETs. Meaning this resistor goes pretty much directly to the battery connector. Well, not even pretty much. It goes directly to the battery connector. So even if there is a little short somewhere here, it would not, well, say this transistor. Oh no, this is a diode, right? Charging DC in and battery in, and this is out. So these are two diodes probably. This is DC in. Yeah, well, we have to check these two, but I'm pretty sure I did already. But not much more than that. Power charging V battery. This resistor, it goes to battery plus. Yeah, so that's our output. So this is our feedback here through this resistor. That's how we get feedback. So we need to confirm that we see the proper voltage over here. Because if the voltage is for some reason too high over here, then that explains why the battery is not charging, because the circuit is fooled into thinking that the battery is already charged. Okay, so that's the plan. I'm gonna get to it, and I will report back in a minute. Well, actually, probably in a few hours. All right, the board is out. Now I have one initial observation over here. Take a look at this. Now, can you tell me why the CPU is overheating? See this? Now, to compare to GPU that is not overheating, see that? And the CPU that is overheating. So it looks like either I messed up by putting the screws on, right? And as you can see, it definitely wasn't sitting flush. Now, I would say this area was not sitting properly. Or the other possibility, we have a bend on the heatsink. It is possible. Third possibility, even most likely one, is the problem that the pad on that side is not sitting right. And look at that. This was not sitting right. So this whole area, because you can see the amount of paste is good, but it was sitting well here, but not here. And that is most likely because of this thermal pad. Now, we did identify it before when we disassembled it, but I did not have a thermal pads for replacement, which I still don't have, but we can see that this is definitely going to be a problem. Even liquid metal is not going to protect you from this. So this there. And there should be one over here, right? One over here. Now, as you can see, those pads are completely torn, but at least now it has a chance of working. So this should be the configuration of the pads. If you worked on this laptop before and you know exactly what the position of the pads should be, definitely drop it in the comment. And if you know what size of these pads is. But if you put two fake pads, the contact with the CPU is going to be not enough. CPU is going to be overheating. If the pads are too thin, then the contact on the CPU is fine, but there's no contact, no proper contact on the MOSFETs and the coils, and they in turn heat up, and obviously the CPU is grabbing that temperature as well, so it's going to impact the temperature of the CPU. Now we're still going to do liquid metal, of course, but I think this is what the overheating problem is, because we would expect the GPU to be overheating, not CPU. And since the CPU is overheating, then this has got to be the issue. All right, now back to charging issues. Okay, just to be sure, I replaced the battery. It looked a little bit different initially, but basically it goes to roughly 12 point some volts, then 14, 13, then it drops to 11.8 on both batteries. Right, both batteries supposedly discharged. Although 11.8 was it? See, now I'm confused. I thought it was 11.2 on the other one. This one is charging with 11.8, which would make sense if the battery is fully discharged. It could start charging with 11.8, because 11.8 is not bad. It will charge the battery and a lot better than at 11.2, because the battery voltage is 11.4. So 11.8, that sounds like charging voltage, proper charging voltage, because you don't want to go too high with it. But I would expect 12 point something. But it also depends on how, if the battery is fully discharged, then the PMC will start charging from lower voltage and the voltage will be growing, and as close to the battery being fully charged, the voltage will be closer to the highest voltage allowed to charge the battery. So I don't know, but I checked the coil with the oscilloscope. It is perfectly fine. There are no fluctuations. There is nothing suspicious that I see on the scope. Everything seems good. It is weird. So I think what we're gonna do is we're gonna replace the PMC, because that's the only thing that I can think of, and go from there, I guess. It's a tough one. All right, looks like you win for now. I give you the win. Temporary. So here's the problem. The PMC is an ISL chip, the Renaissance chip. We only have a short data sheet for this chip, right, explaining its features, which is still relatively useful. But to acquire the full data sheet, you have to register and you have to sign an NDA and be approved, that kind of stuff. I did register. I didn't get the approval yet, and perhaps I won't, so maybe we'll never know. But based on the features of the chip, the description on the short data sheet, this chip has memory. This chip learns the battery, and it has plenty of safety features that prevent any damage to either the battery or the rest of the computer. My conclusion at the moment is that the chip has been put in the mode, in like a safety mode, for some reason. It can be. So the chip has its internal hard-coded hardware protections that it uses to, not overcharge the battery, not overcurrent the battery, not over voltage the system, all kinds of protections. That's why we have those two big resistors, one on the input, one on the output, and the current is being measured so it can detect all kinds of shorts and everything. There are two configurations that are noted in the or displayed in the short data sheet, but none of those two configurations match what I see here. So this is some different configuration that is not documented in the short data sheet. What I could do is just replace the PMC. I have the plenty of them. But why am I not doing it yet? Well, we're going to publish this video first, and we're going to ask the customer what to do with this. Because what are the possible results of replacing the chip? Number one, the best case scenario. This chip is locked, right? We replace the chip. We put the new chip, which has default configuration and everything. Now the chip is configured through the resistor or whatever to tell the chip how many cells we have. We have 1, 2, 3, 4, 5, 6 cells. Looks like we have 6 cells in this, but they're probably it's probably 2 cells bridged together. So as far as the chip is concerned, this is 3-cell battery, because this chip doesn't work with 6-cell batteries. It's anywhere from 2 to 4. So this is probably configured to be a 3-cell battery. So once I replace the chip, it should also know that it's the 3-cell battery. The rest, it reads over a SM bus. It also talks to the rest of the computer. So the best case scenario is that after the chip replacement, the battery charges perfectly fine. It probably, well, most definitely, it first runs in a detection mode to learn the new battery, because as far as the chip is concerned, it's a new battery. Then it starts charging the battery properly, and it works. That's the best case scenario. So basically, the current chip sitting there is kind of is locked in a way, and once we replace the chip, it's kind of like we reset the chip. The chip itself is not faulty. I am 99.9% sure that the chip is not faulty, because that's not how the faulty chip would manifest. The more likely scenario is that I replace the chip and it starts charging the battery correctly, but the system will lock the chip again because of something else wrong on the board, which we don't know and we can't really tell at the moment. But there might be some other fault identified by PCH, and PCH will tell the PMC to not charge the battery with higher wattage than 1 milliwatt. The worst case scenario would be I replace the chip, and since the chip is like in the carte blanche mode, it will cause some damage, meaning it will stop charging altogether. Because at the moment, the charging is slow, but technically it is charging. Technically it is working. And the PMC replacement will not only stop charging the battery, but prevent the computer to work from the battery. So that's the worst case scenario. And then even after we replace the original chip, it will still not work. It is possible. Unfortunately, that is the possibility. So why am I not trying this? This is a $1,000 board, right? It's not going to be easy to replace the board if this goes wrong. Not to mention, this chip also is responsible for powering the system from the battery. So if anything goes wrong there, then we can fry the 4090 GPU on it, which again, it's a $1,000 board if we want to just replace the board. So we're gonna end here. I want to send the video to the customer, and the customer is going to decide whether we want to risk it or we just want to resolve the overheating problem and just computer is what it is. It's not charging with full current. This is kind of a fault that you would probably have to send it to Sorin to fix that. It's a really intricate fault. It's not something that we typically work on, or typical issues like shorted component or faulty chip or something like that. Because it does work, it does communicate, it does its thing. It just does it not the way we want it to do, but it does it as far as the chip is concerned. It is performing correctly. All right, so we're gonna stop here and we're gonna start working on another laptop. And we'll see if the customer wants to risk it. I would advise against it. That's why I'm holding on it, because I don't have much faith in this actually resolving the problem. Because I know the chip, as I said, 99.9%. I know the chip is not faulty, because it would behave completely differently if the chip itself was faulty. We replaced the battery. So we know it's not the battery, but we kind of knew that right from the start. So my recommendation is to just gonna live with it, because this is not necessarily a mobile kind of laptop that you typically use off the battery. It most likely is used as a stationary laptop, meaning you still can carry it, but you don't necessarily use it off the battery. So just treat it like, the battery is there for emergencies, but once you discharge it, you need 2 days to recharge it. I know it sucks, but this is the gaming laptop. I think the overheating is much more severe fault in this case than charging, because overheating actually prevents it from working properly. So that's what we're gonna do. So technically no fix, but I've learned a lot about this chip. This chip actually is no longer recommended for new designs, so maybe this knowledge is not super useful for engineering, but for repair, it's good to know. And if I do get that data sheet, well, obviously if I sign NDA, I'm not going to be able to just publish the PDF, but I am free to learn how it works and then just kind of present it to you guys, how the chip works and how to communicate with it. Now the one last thing that I was thinking, if I do get this chip, my next project after I released the Rework Pro 1.1 would be the NLB device, basically a battery diagnostic device along with the software. Now right now, if you want to get this software, not only it costs a lot of money, but you have to pay every year. So you buy a license per year, or was it per month? I don't even remember. So it's relatively expensive. So to actually acquire that software, you have to have a lot of business to just kind of justify that purchase. What I want to make is, because as far as the communicating with the battery, it's a known protocol. It's basically I2C communication. You just have to detect the address of the battery, and then you have certain, well-documented commands that you can send to the battery to receive the information from it, to unlock it, to lock it, to get the diagnostic data. It is a lot of work though, because there's a lot of reverse engineering of stuff. So it will be hard, but hey, I didn't have much more information on PC410 controllers, and I managed to reverse engineer pretty much the entire protocol. So I'm pretty sure I can do the same here. And this chip, what it provides is not only the ability to charge the battery, but also it converts the SM bus into SPI, which is easier for me to communicate with. So instead of connecting directly to the battery and communicating with the battery, we communicate with this chip. And it also gives us the ability to protect the battery, to charge the battery and all that kind of stuff. So once I get the documentation, I should get, if I get the documentation, I should get the description of the protocol, which means I can easily communicate with it. So that would be beneficial as well. But we'll see what the customer wants to do. For now, I want to keep it disassembled and get it ready for the liquid metal installation if we don't want to address the charging issues. But that's that's pretty much it. You know, this laptop definitely took this fault definitely took a lot out of me, and I hate to walk away from it with a defeat. But it's a lot worse if your defeat is that you broke the $1,000 board. I don't want that either, because that would hurt. That would hurt a lot. You know, if I break the $100 device, it's fine. $150, I'll survive. But a $1,000 laptop, that takes me back months of revenue. So I can't really afford that. So we first need to get an okay from the customer. That's what we're gonna do. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.